Hey there, everybody. Thanks for joining our webinar here. As customary, we're a little earlier. It's right at noon there. Just a quick reminder, we do have a chat on the side of the screen where you can drop questions. If you want to get hold of us before, during, or after the webinar, you can go visit us at simpleray.com. You should also follow us on Facebook or LinkedIn or wherever you like to get your industry news or you want to follow us at. We're going to start doing more of these webinars over time. So today is kind of a soft rollout and getting us going. So we'll give everyone a minute or two here, and while we wait to kick into the meat of our presentation, I'll introduce Shannon Ware, who is with us. Shannon is our managing engineer. She has at least 8 years, I think going back to 2012 is what you were telling me earlier, Shannon, in the solar industry, and is a NAPSAP certified PV installer, and has spent some time on roofs and out in the field as well, which I think we'll get into a little bit later. But really excited to have you and all of your experience on the team, Shannon, and welcome to your first webinar.
Well, thanks. Hope I don't screw it up.
If we screw something up too bad, we'll just delete it and we'll start over sometime. So that's kind of the joy of today. So just a little bit of background on this. A week or two ago, we had a lot of wind events. The derecho, whatever you call it, here in the Midwest, had high winds. In our industry feeds, we saw a lot of installs that fared well and some not so well. I think I heard one in Des Moines might have kind of gone off a roof or something there. But on the sales side, it's kind of a scary question for us, right? Do we even want to talk about these things and introduce doubts in the mind of our customers, or we kind of want to tackle this head on? And in my opinion, and that of the team, is kind of want to tackle these things head on. They're things we're never going to outrun nature, and it's something we should be talking about, and something we certainly think about on the design side. So, the more you know, I think the better equipped people are to make decisions. So our hope is our very informal conversation today is going to kind of open the box a little bit on just how much thought can go into these design decisions, and what we can handle with design, and what insurance is really for. So with that, we've got about 2 minutes in here. We'll go ahead and get started, Shannon. So just remember, you can put your questions on the right, but we kind of have kind of two tracks of questions here. The first one, and you sent me a lot of really good photos and images, but this one on the right really stuck out to me. It's a wonderfully designed system on a house, but the house kind of moved, which is good on the PV system. And I'm just going to kind of ask these questions real quick, and we can kind of dig in where you want. But is there a perfect solution of a system that's never going to fail? Is that even something that we want to design for? Here in the Midwest, are there certain considerations that we're thinking about that may be different? In Canada, maybe you have a different snow load, or on the coast, maybe you have a hurricane. And talking about the hurricanes, kind of talk about how important components are, and there's a lot of different installations that we do. Ground mount, roof mount. So we really just want to start off with that first solution, the golden solution. We try to be consultative in our approach and figure out what's best for our customer. But on the engineering side, what are you looking for? What is a good solution from your perspective when we show up at a customer's facility and we're looking at it?
Well, excuse me. Obviously, like many things, and you have to balance cost versus risk. Like how often is an expected event going to happen? I think that's one thing we're looking at here with these wind events is, for example, the derecho is a very unusual event. I don't know when the last time something like that happened. So do you design for those worst case scenarios if they only happen once every 20 or 30 years? But on the other hand, we know that climate change is real, and some of these events, these extreme events, are happening much more often than, quote, predicted or allowed for in some of our design standards. When we're designing, though, there's usually a design wind speed and risk that's specified by the local authorities, the local code officials, and then there's guidelines from the American Society of Civil Engineers. They have specific design guidelines. So typically the wind speed design are somewhere around 90 to 120. It kind of depends where you are. And it also, we evaluate the risk category of the building. For example, if it's a public building that might have hundreds of people in it at all times, that might have a little more stringent design criteria. So the answer, is there a golden solution? I don't think there is, because, what do you design it to? Do you design it to, a tornado can get up to, 300 miles an hour, 200, 300 miles an hour, possibly an extreme. Yeah. But, if you designed everything to that, this stuff wouldn't be practical. So,
I guess another piece of this, which gets into the components, but, my position, I'm the director of sales and deal with a lot of the policy stuff. And, on the sales side, if you're a sales guy, you want the system to be as low cost as possible. I can't count the number of times that, maybe someone, and they say, yeah, electrician Y or, farm implement dealer Z, their system's, 3% less than your guys' system. Aren't you guys going to match that price? And, we really try to dig in and find out what's going on. Is there a balance there between having a bomb-proof array and, something that, is built on, I don't want to say low quality components, but, something that isn't as durable? How do you balance those two features?
Yeah, well, you're always going to find somebody that's going to quote a cheaper system in many cases. That's true of many industries. And there's usually a reason, because even within our available solar components, you have lower cost and sometimes usually slightly lower quality versus a little higher quality product. So even though we might be, quote, designing to the same, requirements from the code, if you use a more robust system from, a higher quality supplier, it's much more likely to meet those requirements. So that's one thing we have to look at. Plus, we're doing all the required engineering here. And there is a little cost to that. So we have all these qualified engineers on staff. We have outside engineers. We work with the racking companies, for example, that supply the support structures for the racking. They have their own in-house engineering, and they do an engineering analysis. We look at the wind load, snow load, dead load, and the load carrying capacity of the roof. All those things have to be done carefully. And then the third component is workmanship quality. So if you've got an experienced company that's doing this full time, all the time, we're much more aware of all the little details and how we need to do things correctly, so that we're installing it fully to the specifications from the manufacturer and the code.
One thing that caught my eye, and, how our process works is, Shannon and the design team, they're inserted into our quoting process right from the start. I think some other companies, they kind of give the sales team an iPad and they let them go out and do some design work, and they give them some price boundaries to work from. And then if they close the deal, they bring it back. And maybe that's when the internal engineering team would see it. And I think you're working with Josh the other day on a system, and, a lot of the stuff we do here in the Midwest, it's a flat roof or it's located near the ground. I think this particular roof was up 2 or 3 stories, and that caught your eye. And can you talk about that example just a little bit, Shannon, and what we did on the back end instead of just getting a quote out that day, which, on the sales side, we always like to have that proposal, right? But we slowed this down a little bit, and I think it was for good reason.
Well, that's what's important, to get at least an engineering eye, at least to glance at it early on. In this particular case, it was actually a nominal 6-story building, but the upper roof deck was actually 90 feet high. So the higher you go, the higher the wind issue is, or the larger the wind issue is. And so I kind of flagged that, and we queried some of the racking companies, and exactly as I expected. They said, whoa, yeah, we have to do something different here, because our standard solution, this is outside the envelope of that. So in that particular case, we're probably going to what's nominally, it'll look kind of like what we call a ballasted system. We can get into those types, but there probably isn't going to be any ballast on this one. It's going to be what we call fully attached to the roof. Because the wind loads are so high up there, doing it with the traditional ballasted method would have created too high of a dead load on the roof.
Yeah.
in addition to having all these concrete blocks up high, which is probably not a great thing either.
Yeah. So this system really highlights me, there's an infinite number of ways of design and engineering things, it looks like. And, a ballast system, where we kind of put blocks and, the system weighs itself down, that's a potential solution. But then at the same time, in order to get our desired effect of having that remain anchored, we're going to be adding 2 million pounds per square feet for the particular roof. And so you really have to start thinking about what the end goal is there. And so you kind of mentioned, with ballasted roof mounts, we're fully mechanically attaching to the roof. Can you kind of talk about, and you have some slides, I'll go try to find the right one here, but can you talk about the considerations when we're doing something like on a TPO roof or a flat roof, for example? It's not as straightforward as just putting some modules and racking up there.
Yeah, and as in anything, as the industry and gains experience with more and more of these, your typical commercial roof these days is probably going to be a membrane roof, which is usually like TPO or EPDM. And there's 2 major ways to attach those membranes to the roofs. They're typically either what they call fully adhered, where they actually stick it down on the insulation board underneath with adhesive, or they mechanically fasten it periodically. And the latter means that the membrane actually isn't, it's only attached to the point where the attachment points are. So you can actually get in wind where that membrane can flutter a little bit. And one thing that's come to attention is that fluttering in some cases can actually cause things on top of it to walk around a little bit, like the solar array. So what we're seeing sometimes now is a recommendation for a hybrid system. Even if it's nominally a ballasted system, the roofing companies, or in some cases a particular industrial insurance company that's also highlighted this, may want some additional mechanical attachments to supplement the ballast. So, every case is a little bit different and every building's a little bit different. So that's all evaluated by the various engineering groups.
Yeah, I kind of mentioned earlier that when we're out giving proposals, we're trying to dial in our proposal. So, it is the final proposal our customer is going to see. Sometimes we run into proposals where another company has an extra 10, 20 kW up on the roof, and they have modules going edge to edge, and that wind lift and that system walking around as a result of maybe that design process early on. And so there's a trade-off. Do you want to maximize the amount of modules you're getting on the roof, or do you need to not only take into account code, but also these wind loads?
Sure.
So I have the image up right now of the ASE 710 roof zones. Can you kind of talk me through that slide and what we're looking at here?
Sure. And this is an example of evolution, as they've gained more experience. The newer version of ASE, they've changed how they want it evaluated. But the zones in the outside area are subject to higher wind loads. And especially the corners, which we've known about for a while, but it wasn't in the ASCII 710, particularly like it is in the 16. So those red corners there, you actually can get what are called wind vortices at those corners, much higher uplift forces. So we like to try to kind of stay out of those when we're designing. We can put modules and arrays into some of these edge zones because sometimes they're pretty far in depending on the height of the building. But it just means that you're going to have either more ballast or more attachments in those areas because the forces are higher. So that's one of the things we look at. So, but if we can fit an array inside the green area, then that's what that would be our preference, because that will reduce the loads overall on everything.
Okay. We're about 15 minutes in here. There's a few more things I want to touch on. We can open up for questions, and if no one has questions, we've got a few more slides we can cover. But a lot of this, we're talking about, you're sitting there behind the screen or on the phone talking with our sales team and our customers about the options that we have and how we design a system that, we think is going to sit out there for the next 25, 30 plus years.
Correct.
And then, we kind of talked about earlier when we were prepping for this is your experience in the field, right? And so it's one thing for us to install, say, the same exact component to someone else, but the install actually matters a great deal here. And, what components and what pieces of the install are really important to make sure that the system holds up like it's spec'd out to do.
Well, obviously, the most critical thing is exactly how it's attached to the roof. What you're seeing here is a rail, what we call a rail system. It's a little fuzzy, but I'm assuming that's actually probably a shingled roof, although you can't see the shingles. But that is like a pitched roof. And so typically the modules are parallel to the surface of the roof. And so in this case, they're mounted on these, the rails you see, but then those rails have to be attached to the roof structure underneath. So we need to worry about, are they properly attached so they have the uplift resistance we need. And of course, we also need to worry about proper flashing and sealing to prevent any roof or water leakage. So those are some of the issues we look at. And then again, you might balance like the rails from a number of vendors are available in different thicknesses. So the thicker the rail, the longer the span you can go, and maybe lower the number of attachments. So those are some of the issues we look at. So sometimes it's very roof specific to a particular job, what the correct or the best solution seems to be.
I was just looking for it, but I didn't find it in my quick search. We're talking about a hurricane, and we were talking about clamping methods, and I think you had mentioned, torquing everything down earlier, and
yeah.
We saw an image up where the end of a row of modules had not been torqued properly, and that end clamp came off. Can you kind of describe that zippering effect if everything's torqued down properly?
Yeah, this really came up. There was an analysis done on what happened at Hurricane Maria in Puerto Rico. There were some arrays that really had some. Of course, that was an extreme event, so they were already, the wind there actually exceeded the design wind for the array, so that was part of it. But they still examined how the failure occurred, and they were hitting like 200-mile-an-hour winds, I think there. So not something that's real common here. But like an end clamp that might not have been torqued down quite tight enough, maybe wiggle loose on one of these rows. Like we're talking about a ground mount array now, where they're out in the fields and they're in the long rows. And so that one end module kind of comes loose, and then it comes loose and the wind kind of puts it up and it bends the mid clamp between it and the next one. And then they just kind of the whole row can unzip and come loose. So there were some recommendations that came out of that, primarily if you're expecting hurricane force winds. So that's just one of the failure mechanisms, but it's also why we need to make sure when we're doing our workmanship and our installation that we are properly torquing clamps and things, because not only is under torquing an issue, but over torquing could be an issue too, because it would if you over torque and you stress a fastener, for example, it might be more likely to snap or shear. So to me, and pulling back the curtain a little bit is realizing that a lot of these systems, they're not just one single component. They're meant to go together as an entire system. So if you create a weak link, you really expose a lot of the rest of the system up for more points of failure. So that end clamp really is locking everything together. And as long as everything's locked together, it's incredibly strong. But I kind of think of it like a box. If you break one corner of a box, you can really tear apart the rest of the box really easily, even though it was a very solid and durable structure before. Well, I see we're pretty far into the webinar. I don't see any questions in the chat box, but if anybody has any questions, please pop them up there or or let us know if there's something specific you'd like us to address.
You can even say, more Shannon, less Lewis. That would be a perfectly okay piece of feedback there. I'll take this brief pause to kind of highlight. Not only do we have Shannon and her team and everyone on the engineering side, doing great work for us, but also when we're out installing, we try to budget time for all these projects to be installed correctly, and then we do offer the 2 years of annual checkup visits. And part of those checkup visits is checking the torque on everything that we've installed, checking those brackets, just to make sure everything's sitting right and tight, so to speak. And we do offer that 5-year workmanship warranty. So, other people might have the exact same racking and, the exact same componentry, But the design or the attention to detail in the design can just be a little bit different, and then the install can be just a little bit different. So that's why we like to self-install whenever possible.
No, I think that's great because when you have your own experienced crews, it really makes a difference. So some of those. Here's an example of the design wind, and
is that the right one? Which one did you want?
Go back one. Okay. Sorry. Yeah, right there. That's a good one. This is some engineering studies that were done a few years ago, but they show how, I don't know if you can tell, but like at the bottom one on the right there, that arrow is showing wind coming in at 45 degrees in a flat roof, and it creates these little like horizontal tornado vortices on each side, and that creates a lot more stress on the roof itself and on anything that's on the roof. So
yeah, I went to a roofing expo down in Dallas, big roofing expo, and they had a little breakout session on solar systems on the roof. And I used to go to the solar expos, and everyone says solar is the best thing ever. And then these roofing guys did not like solar, or their only experience had been a very negative impact. Someone came in, put up a system, didn't do their due diligence, left a bunch of bolts and puncture items on the roof, or they didn't design it with these wind forces in mind, and it really scared a lot of these roofing guys away from ever wanting to ever be involved in a project. But as soon as you kind of talk to them and address some of these issues head on, they soften up a lot, and they're there for their customers, and they just want to make sure that their product is going to be in there for the long haul as well.
Well, one issue, solar is comparatively younger industry, so you can go back to systems that were put in 10, 12 years ago, and maybe there were mistakes made, but the lessons have been learned. And I think the current standards are very good. There's much more awareness of all these issues. Even things like being careful when you're walking around on a membrane roof, because if you got like sharp gravel in the sole of your shoes can punch little holes in it. So that's where the experience of the crew and the team, understanding these things and watching out for these things makes a big difference too.
Well, I think we're over 20 minutes into it. I think we've covered a lot of ground. I think we're ended on a high note, talking about lessons learned and how the industry is in a much better spot than it was, when you started there. So want to thank everyone for attending, or if you're watching this on YouTube, drop a question in the comment. We'd love to answer it. Even if you're not in the Midwest and our core clientele, happy to talk with you on the phone and share our advice if we can. You can reach out to us. I am Lewis Butler at simpleray.com. Shannon is Shannon Ware at simpleray.com. You can give us a call. Thanks for watching, and have a great day there, everybody.
Yeah, thank you, Lewis.